Good afternoon. Uh, with section 6 here that we are finally in, um, we are finally going to be using congruent triangles in real-world applications. We will still be using proofs, and we will still be trying to argue how we know something is congruent. But at this point, we're trying to switch over to real-world applications. The basic thing that you need to learn is something we should already know, is that corresponding parts of congruent triangles are congruent. I simplify this statement to be CP/CTC. Corresponding parts of congruent triangles are congruent. However, I would suggest writing it out until you have it memorized. And by definition, if congruent triangles have congruent, that was horribly written. Please ignore this if here. By definition, congruent triangles have congruent corresponding parts. We can use this idea to find distances across rivers and other hard to measure distances. And that's one thing that we can do. So let's just, in your book they had a hang glider, and they said, hey, how do we know that this part of the hang glider is congruent to that part of the hang glider? So how do I know that I need to maybe buy this much string for both of them? Well, explain how you will use the given information to prove that the parts are congruent. It just says explain, it doesn't actually say prove. The first thing I would do is kind of identify to myself where it is. So angle CAB is this angle right here. Angle CAD is this angle right here. They're congruent. Angle ACB is this angle right here. Angle ACD is this angle right here. I have two angles being congruent to two angles in another triangle. All I have to do is show one corresponding side is congruent, and I can show those two triangles are the same. And hey, if I know those two triangles are the same, then I can very easily say segment BC and segment CD have to be congruent because they are part of a congruent triangle, or part of congruent triangles. So the first step is to show that two triangles are congruent. Triangles ABC and ADC. And I know they're congruent because angle side angle. Congruence postulate, because the two angles are given, and I know segment AC is congruent to segment AC. Okay, so I'm saying this triangle here is congruent to this triangle here because I have this angle, this side, this angle, this angle, this side, this angle matching up. Angle side angle, okay, I have those triangles being congruent. The next part is, now that I have the triangles being congruent, segment BC has to be congruent to segment CD by CP/CTC. There's no way around it. Because they asked me to explain here, I'm not actually going to do a proof. I didn't give every single reason, and I didn't exactly put down every single step. But I outlined how I would do it. I said, first I'd show the triangles are congruent. I know they're congruent by angle side angle, because there's something with segment AC being congruent to segment AC. After I have those triangles being congruent, it just naturally follows that the two segments I'm looking for are congruent. That's all I really did, is I explained my thought process here. If that's what they ask, this is what you do. Now, if I said instead, use this information to write a plan for a proof, well, let's look at what I have here. I have angle 1 being congruent to angle 2, angle 3 being congruent to angle 4, and what I'm trying to show is that triangle BCE, so this triangle right in here, and triangle DCE are congruent. I don't care about any other triangles, I just want those to be congruent. Well, I already have one of their angles matching up. Oh. And I think I also have segment CE here. It's congruent to itself. So I have a side and I have an angle, side and an angle. If I could show that the last side here, segment CD and segment CB are congruent, I would have two congruent triangles. And that's what I'm going to say here. In these two triangles, we know that angle 1 is congruent to angle 2. We have segment CE congruent to itself. And if I can show that segment BC is congruent to segment CD, then I know the two triangles are congruent. Well, to get segment BC and segment CD congruent, what I'm actually going to look at is triangle ADC and triangle ABC. The reason is in those two triangles, sorry, I actually said BCA in triangle DCA, I know that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and I know that this segment here, segment CA, is congruent to itself. So triangle DCA and triangle BCA have to be congruent by angle, side, angle, angle, side, angle. And that's what I just said down here. Wait, so I was originally trying to get these two triangles to be congruent, and if I could show that these two segments are congruent, I've got it. And I then said one way I could show these two segments are congruent is by showing that these two triangles are congruent here. I did that. So now it just naturally follows that I can now say segment BC is congruent to segment CD because of their corresponding parts of these two triangles, and therefore they have to be congruent. And then consequently, I would then say the triangles that we're trying to show are congruent by side, angle, side, congruent, slash, slit. They don't look congruent, do they? However, because of the proof and what was given to us, they are. And that's it. I've now planned my proof. I'd have all the information. I would know where to end, what's the last little thing to make it topple over, and I probably could write a decent proof from this. But all they asked was to write a plan for a proof. I'm done here. The last one, let's actually do a proof. In your book, your example 3 says, prove the distance across the river is 1 mile. Okay, in my example here, we have a river right here. This segment here, BE, is the shore of the river on one side. This here is the length across the river. What if I wanted to know, hey, how far across is the river? Well, I'm not going to take meter sticks and measure it across. That would be near impossible to do. So what if I instead use this idea of congruent triangles? Well, I want to show that the river here is actually 1 mile. And I know that segment AB is the distance across the river and segment BE is along the riverside, the shoreline. I also tell you that I have measured this out. Segment BC and segment CE are congruent. I also know that length of segment DE is 1 mile here. Well, first part of any good proof is to write down the given. There were 3 things that I was given, but I'm going to hold off with length of segment DE is 1 mile. But I'm going to write this down, and I'm also going to write down that angle E and angle B are right angles from the diagram. It's marked that they are right angles. So I have angle, side, angle, side. I'd prefer to get an angle. Angles are always easier because angle, angle, side, or angle, side, angle works. If I look at angle A and D, I don't know if these would be somehow congruent. The only way I could tell you is if I had 2 things being parallel, like segment AB and segment DE. If they were parallel, I could say something about angle A and angle D, but I can't. However, what about this angle? BCA right here, and angle DCE, this angle right here. Those 2 angles are vertical angles, so don't they have to be congruent? Well, yeah. So these 2 angles are congruent because all vertical angles are congruent. I also know that angle E and angle B have to be congruent because all right angles are congruent. So I have angle, side, angle, angle, side, angle. I have 2 triangles being congruent by angle, side, angle. Alright, now that I have the 2 triangles being congruent, I'm looking for the length across the river. So what if I then said something about segment DE, which I know is 1 mile, and segment BA? Well, they have to be congruent because the 2 triangles we're talking about are congruent, and they happen to be corresponding parts. Well, if I'm going to talk about lengths, I really then should say that the lengths are equal. Length of segment BA equals length of segment DE, and that's the definition of congruence. That given that I've waited to write down is right here now. If I know that length of segment DE is 1 mile and I know that the two lengths are equal, I know that the length of segment AB has to be 1 mile. And that's a substitution property. Yeah, this is a little bit of a long proof. But what we did first was we had to show the two triangles were congruent. Then we used that information to show parts that I was interested in being congruent. Yeah, if I want to measure the distance across a river, I can actually measure the distance on dry land and use two congruent triangles to find that distance across. Just I have to be able to measure this angle and this angle pretty accurately. I have to choose a spot on the shoreline that is perpendicular here, and when I walk all the way down here and look from here, I'm looking at the same exact spot. So it would have to be something like a fence post or a sign, or maybe somebody that is standing on the other side of the river. I don't know, but we could do this very easily. If I was here and I looked across and somebody was standing here, and I made sure that I walked at a right angle to them, and I kept walking until I decided to stop, maybe 100 feet later. Then I turned at a perfect right angle and continued to walk to point D here, and then turned all the way to look at the person standing at A. I know that I could find the length across the river just by measuring the length of segment DE here. Alright, that is it for this part. Yep, all you're going to be doing here is showing that triangles are congruent. You're either going to be writing plans for proofs, or you're going to be explaining them, or you're going to be saying, hey, I know these triangles are congruent by angle, side, angle, angle, side, stuff that we've done before. Yeah, that's all we have for you today. Till next time.